Good morning. This is our introductory video on right triangle trigonometry, and we begin today with a look at the trigonometric functions. So I've started by drawing a couple of right triangles here at the top of the page. And what we're going to do is list for these triangles the three side lengths: opposite, adjacent, and hypotenuse. Okay, the hypotenuse in a triangle is always located directly opposite the right angle. So the hypotenuse will be here. The opposite and adjacent sides are labeled once we determine which angle we are referencing. So if I put the angle theta here, then this side length is opposite it, while this one is then adjacent to it. If theta instead is here, if we're referencing this top angle, then across from theta will be the opposite side length, and next to it here will be the adjacent side length. So the hypotenuse is always labeled first, and then the other two side lengths are placed once we determine whether we are referring to this angle or this one. Okay, now there are 6 trigonometric functions. 3 of them are considered main functions, and they are sine, cosine, and tangent. And you will find these ones on your calculators. There are 3 functions that are reciprocal functions. These ones are not on your calculators, and they are cosecant, secant, and cotangent. Now, each one of these functions is simply a ratio of 2 of the side lengths in the triangle. So sine is opposite over hypotenuse, while cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you take the opposite side length and you divide it by the hypotenuse, you have then figured out the sine of the angle, and so on. Now these are the reciprocal functions. So reciprocal meaning that cosecant is 1 divided by the sine of theta. It is also then the reciprocal of O divided by H. So it is H divided by O. Secant is the reciprocal of cosine. So it is 1 divided by the cosine of the angle. It is 1 divided by A over H as well, which makes it H over A. Finally, cotangent is the reciprocal of tangent, and therefore it's the reciprocal of this fraction as well. It is A divided by O. Okay, so in the rest of this short introductory lesson, we're going to do a few examples that will allow us to become accustomed to these things here. The other thing we should mention, of course, is that since these are right triangles, the Pythagorean Theorem applies, and it is true that the square of the hypotenuse will always be the sum of the squares of the other 2 sides, or h squared is a squared plus o squared. Okay? So we end up with the Pythagorean Theorem, of course, holding true as well. So let's just try this example. Write the trigonometric functions for the angle whose terminal side passes through the point 5, 3. So the first thing we're going to do is draw this triangle. So I'm going to say that this is the origin right here. So this is where, in other words, the x and the y axis would meet like this in our Cartesian plane. So what we want to do is go 5 units to the right, since x is 5. So 5 units to the right, followed by 3 units up, since y is 3. And that way we can locate this point. So I'm not going to do this to scale necessarily, but okay, I'm just going to say that that's 5 and that is 3. Okay? And that was meant to be perpendicular there. I went a little bit beyond 90, but you get the idea. So we went 5 units to the right, 3 units up, and that got us to this point, 5, 3. And of course, this point would be 0, 0. And so now what we do is we connect the origin to that point like this. And so this is the angle in question down here. Okay, this is the angle whose terminal side passes through the point 5, 3. So the point again, 5, 3 would be here. This is the beginning point of the angle, and this is the ending point of the angle. So theta is here. Okay, so we have 2 of the 3 side lengths labeled for theta. Now, we can also state with certainty that 3 is now the opposite side length for this angle, while 5 is the one next to it or adjacent to it. What we don't know currently is the hypotenuse length. But luckily, we can use the Pythagorean Theorem to determine this length. So we have here, h squared is 3 squared plus 5 squared. And that's 9 plus 25, which is 34. So h squared is 34. So h then will be the square root of 34. So this is roughly 5.83, okay, if you work it out on your calculator. The hypotenuse, of course, will always be the longest side in the triangle. So that side length is longer than the other 2 side lengths. All right, now all we have to do is form these ratios. So sine is O over H. So we will write 3 over root 34. Just like this. Better not to make this a decimal approximation since we are now forming fractions. So we'll keep radical form here. Cosine is A over H, so it's 5 over root 34. And tangent is O over A, so 3/5. Okay, cosecant is H over O. It's also the reciprocal of this fraction. So it's root 34 over 3. Secant is H over A. So root 34 over 5. Okay, so we can just literally flip these fractions here. And cotangent A over O, which makes it 5/3, and the reciprocal of 3/5. And that's all that was required for this example. So again, this will always be the x value. This is the y value. You can label them. You calculate the missing side length using the Pythagorean Theorem, and then you just set up your ratios. Okay, now let's do these problems. Determine the sine, cosine, and tangent, so just the 3 main trig functions now, for each acute angle. And this, of course, is an important point. If we're talking about an angle that is acute, we mean an angle in quadrant 1, which means an angle between 0 and 90 degrees. Okay, and this means that in that quadrant, all trig functions are positive. Okay, so this is important to note for now. Later in this very unit, we open up this kind of problem to consider angles in all quadrants. But for now, we're focusing only on quadrant 1 angles. Okay, the cotangent of theta is 2.4. Now remember what cotangent means. It means the adjacent side length divided by the opposite side length. If I can make this a fraction, then I can state the values of A and O. So that's my objective, to take 2.4 and turn it into a fraction instead of a decimal. Okay, so there are a lot of ways you can do this. One way is to note that 2.4 is of course the same as 2.4 over 1. Now we don't like having a decimal inside of our fraction. So we can make this 24 over 10 simply by multiplying the top and the bottom by 10. And then we can reduce the fraction now by removing a factor of 2 to get 12/5. So we're saying that 2.4, the original 2.4, is the same as 12 divided by 5. And I mean, you can check that it is. 12 divided by 5 is certainly 2.4. Okay, now if you didn't like this kind of analysis, you can start to get acquainted with the button on your calculator, the fraction button here. I'll show you what I mean, okay? So I've got it cleared. If I put in 2.4, I have to push equals so that the calculator can see the number. Okay, so 2.4 has been entered. Now look what happens if I hit the fraction button. It's telling me that 2.4 is the same as 2 and 2/5. So it's a mixed fraction, 2 and 2/5. If I want to instead have an improper fraction, which I do because I just want one number in the numerator, one number in the denominator, I can hit Shift and hit that fraction button again, and look what it'll give me, 12/5. Okay? So you can do this all the time. Let's suppose you wanted to figure out the fractional equivalent of 3.6. Then you'd go like this, 3.6, put it in the calculator by pushing equals. Hit the fraction button. 3.6 is 3 and 3/5. 3 and 3/5 as an improper fraction, Shift, button, and now we'd have 18 over 5. So that was just another example of taking a decimal and converting it to a fraction. I'll do one more. Let's say it was 0.35. 0.35, put it in the calculator, hit the button, 7/20, and you're done in this case because you didn't get a mixed fraction. 7 over 20 is the equivalent of 0.35. Okay, anyway, now that we've got the correct fraction in its lowest terms, we know that cotangent, remember, is A over O. So I know now that the adjacent side length is 12 and the opposite side length is 5. And I could draw this if I want. Or I can simply note that all I need to complete the problem is to figure out the length of the hypotenuse. And how can I do that? I can use h squared will be 5 squared plus 12 squared. And this is 25 plus 144, which means it's 169. And h is the square root of 169. And when you take the square root of 169, you get 13. So now I have 1, 2, 3 side lengths for the triangle, so I'm ready to write out the 3 trig function answers. So sine, remember, was O divided by h, so it's 5 over 13. Cosine was A divided by h, 12 over 13. And finally, tangent is O divided by A, so it is 5 over 12. And now we're done. We've completed the problem. Okay, let's do one more together. It says the cosecant of the angle theta is 1.6 repeated. This means 1.6666666. The sixes go on and on forever and ever. Okay, again, our objective is to make this into a fraction. And it will be an improper fraction because it's more than one, right? More than one gives you an improper fraction. Improper meaning that the top number is larger than the bottom number. Okay, many of you might know already that 0.6 repeated is the fraction 2/3. So what we have here is 1 2/3. If you recognize 2/3 as being 0.6 repeated, then you could go right to this step, and then it's very easy to take 1 2/3 and change it to an improper fraction. You do 3 times 1 is 3, 3 plus 2 is 5, and you get 5/3. So 1.6 repeated is 5/3. Quick check, right? You could do 5 divided by 3. See, 1.6 repeated. Okay, if you didn't know that 0.6 repeated was 2/3, you can start by putting this number in your calculator right here. Now, you have to put in sixes for days. Not just a little bit and try hitting the button, okay? It's not gonna work. You have to put in sixes, lots. Look. Okay, then push equals, right? Now hit the fraction button. 1 2/3. Oh, that's helpful, right? And then from there, if you want the improper fraction, shift button again, 5/3. Okay? Now I'm using a Casio calculator. You're gonna have to, if you have something different, you're gonna have to see. But I believe that the fraction button will work in the same way on all scientific calculators. So again, the one thing is don't just put in a few sixes like this and then try to do it. See how it's not working? You have to fill it up, fill up the whole screen, plus a few more. Then push equals. Now hit it. 1 2/3 or 5/3. Okay. Now we know cosecant of theta is 5 over 3. Cosecant of theta is h divided by O. So now we know the hypotenuse length and the opposite side length. So over here, the missing side length was h, the hypotenuse. What are we missing now? The adjacent side length. Well, that's no big deal. If we want to figure out the adjacent side length, we're going to still use the Pythagorean Theorem, but of course we're going to have to be using subtraction. So a squared will be h squared minus o squared. Like this. Okay, so that means we're doing 5 squared minus 3 squared, which is 25 minus 9 or 16. And a is then the square root of 16. A is 4. And now we're completely set because we know h, o, and a. So we can set up our trig functions, which will serve as our answers. Okay, so sine is O divided by H. Cosine is A divided by H. And tangent is O divided by A. These ones are very nice to express as decimals as well if you prefer. These would be 0.6, 0.8, and 0.75. So you can either leave them like this or like this. 3 divided by 5, 4 divided by 5, 3 divided by 4. And you get these nice familiar decimals. We don't have to do any rounding. Okay? Okay, so that's it for our introductory trigonometry lesson. In the next lesson, we will focus quite a lot on the distinction between angles and trig functions. So stay tuned for that. Thanks and have a great day.